Hi, ladies and gentlemen. This is Mr. Green, and I am making another in my recording for Algebra 2. This one is going to be dealing with absolute value inequalities. Now, we remember the absolute value situation. It's that one with the little lines on it. I mean, nothing particularly fancy here. We use absolute value like that, straight up and down lines. What you're going to see is that it represents unbounded intervals using interval notation, and we're going to solve some inequalities using giving the solution set graphically and using interval notation, and we're going to represent unbounded intervals using interval notation and solve some compound inequalities and give a solution set graphically using interval notation. That's what we're going to be talking about when we talk about absolute value inequalities. Now, what does all that mean? It means that when you're looking at an absolute value function, when we looked at it with equal to, we said it was the units that were always away from the zero. We went 3 units both directions. We had a -3 and we had a +3 in this situation because 3 was equal to the absolute value. And what we told you to do to solve this, we said you came up with two solutions. You had x is equal to 3 and x is equal to -3. And see how we're putting the negative sign out here and this one here? And it was either or, one or the other, right? Well, that's what we're going to be doing here with inequalities too. But there's a trick to inequalities. When you look at a less than inequality where it's pointing at the absolute value, you're always going to get a conjunction. See, when it's pointing at the absolute value, it's a conjunction. And when it points away from the absolute value function, I want to use the other one, that one, my favorite one. When it points away from it here, then we're going to get a disjunction. Okay? So these are ors. These two are ands. And how do we represent ands graphically? Well, these are just a line segment. It's either with the unbounded with the open circles on them or bounded with the closed circles on them. And the inequalities down here with the disjunctions are the ones that are the rays that are going in opposite directions, either or. Okay? And how do we express those in our set? How do we express those here? We write them as inequalities so that we can look at them correctly. Okay? Well, let's go ahead and try a couple of these. So here we've got one that says the absolute value of 5 plus 6x is less than 3. Well, I see this. It tells me and so what I'm going to have is 5 plus 6x less than 13 and 5 plus 6x is less than -13. Okay? So let's see here if we can't work this out. Okay? So what am I going to do? I'm going to subtract 5 from both sides of this equation, and I'm going to get 6x is less than 8, and I'm going to divide by 6. I'm going to x is less than 8 over 6. Well, that's a little bit, I can reduce that a little bit, and it's going to become 4 over 3, and that's going to be equal to 1 and 1/3. Okay? So that means that x is less than 1 and 1/3. Okay? Let's try this other one over here. We subtract 5, and we get 6x is less than -18. And we divide by 6, we get x is less than -3. Oh, I wrote that incorrectly, didn't I? Greater than, and greater than, and greater than. I'm sorry. I forgot to, when I took the absolute value off there and made this a negative here, I needed to switch the sign on this one, the alligator. Let's go back and look at that real quickly. If you notice here, it's pointing at this. It's going to be an and. It's greater than the negative and less than the value. Greater than or equal to the negative and less than the value. And I didn't do that here. I didn't change this to greater than, did I? So it's going to be x greater than negative 3 or x and x less than 1 and 1/3. So if I put my 0 right there, my negative 3 is out here. It's going to be an open circle around the negative 3. And I'm going to come out here and say, well, there's the positive 3 out here. There's the 2. There's the 1. 1 and 1/3 is going to be right in here. It's going to be an open circle around the 1 and 1/3. And it's going to be everything in between those two. This is 1 and 1/3. Third. Come on, pencil. Third. Okay. Okay. If that hasn't confused you enough, let's try another one, see if I get a little bit better at doing these, okay? So here we've got, and it's less than or equal to, and it's pointing at the absolute value sign. So I'm going to say 5 times the absolute value. Well, wait a second, I'm just going to make that into a parentheses right away. 2t minus 8, parenthesis, less than or equal to negative 20, and 5 parenthesis 2t minus 8 parenthesis greater than or equal to 20. Okay? So when I divide by 5, I get 2t minus 8 is less than or equal to minus 4. And I add the 8 to both sides. I get 2t is less than or equal to 8 and 4 is 4. Divide by 2, t is less than or equal to 2. Come over here, I divide by 5, and I get 2t minus 8 is greater than or equal to 4. I subtract the 8, I get 2t, or add the 8, is greater than or equal to 6. No, I'm sorry, 8 and 4 is not 6. 8 and 4 are 12. And when I divide by 2, I get 2t is greater than or equal to 6. Now I want you to notice what I've got here. I've got that t is less than or equal to 2 and t is greater than or equal to 6. Wait a second. That didn't quite work out, does it? Here's 0, here's 2, here's 4, here's 6. If it's less than or equal to 2, that's a solid point here going this way. And greater than or equal to 6, that's a solid point here going this way. This is not a conjunction. Those are going opposite directions, aren't they? What's the problem with this? The problem was right up here at the very beginning that we didn't even look at it very closely, did we? How can we ever have an absolute value equal to, less than or equal to, a negative number? It can't happen. And because that can't happen, there is no solution to this one. Okay? So you need to be able to look at these and look at them first. You can go through the entire work like I did right here, and you wind up with a disjunction. But wait a second, it was an and so it was a conjunction. But how could a conjunction develop it can't. No solution whatsoever. You have to be aware of these type of things and be very careful with them. Okay? So looking at this one, I got absolute value of h plus 6. Oh, I've got a greater than. This one is going to be a disjunction. This one's going to be an or statement in here, right? Well, the first thing I'm going to do is I want to get rid of this. I don't like dealing with fractions, so I'm going to multiply by 3 on both sides of this equation just to get rid of it, and I'm going to get the absolute value of h plus 6 has to be greater than or equal to, absolute value there, sorry, greater than or equal to 12. Now, disjunction. H plus 6 is greater than or equal to 12, or h plus 6 is less than or equal to 12. Okay? So I now have subtracting 6 from both sides of the equations here, like this, and I get h is greater than or equal to 6, and h is less than or equal to negative 18. Okay? So that's where my values were. 0 here, negative 18 is way out here. It's going to be less than or equal to, so it's going to be a solid point here going that way. And 6 is over here somewhere, and it's going to be a solid point there going that way. Okay? So remember, tricks to this one are get rid of this value here on the bottom first, right? Get rid of the fraction. No one likes dealing with fractions. Break it up into the two or statements. Don't forget to put the negative sign on this one. Okay? And then solve them independently, and you get two different values that you can go from. Let's look at another one here. I've got absolute value of x minus 1 is greater than negative 3. Wait a second. Okay, if it's going to be greater than a negative number, well, that means it's got to be, greater than 0, right? Because it can't be just negative 3, because that won't get us a good value, will it? Well, let's go ahead and write it down anyway. So we get x minus 1 greater than negative 3, or x minus 1 less than 3. That was a minus 1, sorry. Minus 1. Okay, so I'm going to add 1 to both sides of this equations. And I got x is greater than negative 2, or x is less than 4. Okay, well, let's put 0 here. And we go to negative 2 over here. And it's going to be greater than negative 2. That's going to be an open circle going that way. And over here we got 4. And we got an open circle going that. Wait a second. Conjunction. They're hitting each other. This is not a disjunction at all. I thought this looked funny. When I see this negative 3 here, that's going to tell me right away. No solution. Okay? What happens if I stick a 4 in here? 4 minus 1 gives me a 3. Is 3 greater than negative 3? Yeah, it is. Okay, that gives me a solution. What if I stuck a 1 in there? 1 minus 1 is 0. 0 greater than negative 3? Yeah, it is. I mean, that does work. Okay? What about negative 2? If I stick a negative 2 in here, negative 2 minus 1 gives me a negative 3. Absolute value is 3. Is that greater than negative 3? Yeah, that one is too, right? So what are we doing wrong here that's causing this to be an absolute value, not to work, to give us a conjunction? We should be getting a disjunction. And we should be getting two different lines here. Let's see here. What could we look at? What about 4? At negative 4, if I stick negative 4 in, negative 4 minus 1 is a negative 5. Negative 5 absolute value is 5. 5 is greater than negative 3. Wait a second. I'm still seeing a problem here. What about 5 out here? If I stuck a 5 in here, 5 minus 1 is a 4. 4 is greater than negative. Everything's greater than negative 3. Everything I stick in here is greater than negative 3, because these two disjunctions are going to be pointing at every number in the real number system, aren't they? What about 0? 0 minus 1 gives me a negative 1. Absolute value negative 1. So 1's greater than negative. Everything is there. So there's no solution to this one, because we're trying to compare it to a negative number. And absolute values compared to a negative number, whether it's a conjunction or a disjunction, just don't work. You can't get them. You can't get a single solution to them. It becomes impossible. Okay? So, what are we looking at? comparing, making certain you're looking at those absolute values real carefully, okay? You got to remember conjunction and what are you going to do? When you flip the sign, you flip the sign, okay? And conjunction and when you flip the sign, you flip the sign, right? Oops, circling the wrong one. When you flip the sign, you flip the sign, okay? Over here, ors, disjunction. When you flip the sign, you flip the sign. When you flip the sign, you flip the sign. That's the way the ors work. Okay, I am available in tutoring. I'm available to be contacted just in Kmail. Make certain you send me the course name telling me you're in Algebra 2. It helps me find you quicker and give you answers quicker. Hope you enjoyed it. Talk to you later next time.